Before we actually get to solving a mixture problem, I'd like to go over a big idea that we're going to see in mixture problems. And this problem illustrates that big idea. We're told that we have two containers, and these two containers contain two different solutions. The first container has 5 liters, and that's 5 liters of a 34% alcohol solution. That's what we see here on the left. This is 5 liters, and the solution contains 34% alcohol. The second container has 7 liters, that's this larger container, and the alcohol solution is a 26% alcohol solution in that container. The question I want to ask is, do they have the same amount of alcohol? In other words, what is the alcohol content in this left container? What is the alcohol content on this right container? And are they equal? This idea of comparing whether or not things are equal, but comparing alcohol content is going to become important. And it's a good idea for us to look at this problem and see how it translates into mixture problems. So let's look at this first part here. If we know we have 34% solution, and that solution is 5 liters. If I wanted to know the alcohol content of this solution here on the left, I would take 34% of 5 liters. And doing so would give me the alcohol content. Now this is just, in this case, we're talking about alcohol, but we could be talking about acid, we could be talking about a whole bunch of different solutions that are part of or mixed into a particular, whether it be water or other type of solution. So if I'm looking for what is 34% of 5 liters, what I would need to do is to take 0.34 and I would multiply that by 5. And when I do that, when I take 0.34 and multiply it by 5, I get 1.7. Now this is 1.7 liters. We're going to assume this is also a volume. This is 1.7 liters of alcohol. So this is the alcohol content for this mixture here on the left. What I want to know, does that match the container on the right? Well, in this case, I don't have 5 liters. I have 7 liters of this larger container. So what I want to look at is what is 26%, since we're looking at 26% of 7 liters. So I can take 0.26, I can multiply that by 7, and when you take 0.26 and you multiply that by 7, you get 1.82, and again this is liters. So the original question that we had was, are they equal? Do they have the same alcohol content? And looking at this, knowing that this is 34% on the left-hand side, we got 1.7. On the right-hand side, this has 1.82. These are not equal. Now, why are we taking the time to look at this? This is not a mixture problem. Well, when we go over the example for the mixture problem, the important thing that we need to consider is when we are mixing two containers and they are producing a new container of solution, their alcohol content must be equal. I'll say that again. If you are mixing two solutions, so let's say we had two solutions. Here's one box, here's another box. We're going to add them together, and that's going to produce a third box. So, and I say box, but this is just a picture to help us draw. If I had two solutions and I mix them together to produce a third, what I know, if this statement is true, if I mix these and it's equal to this final container, then the alcohol content on the left-hand side needs to equal the alcohol content on the right-hand side. And the two pieces of information that are going to be important in finding and solving mixture problems are the concentration and the volume. As we saw in this problem, in order to describe the alcohol content of these mixtures, we needed to talk about the concentration and the volume. What makes mixture problems complicated is that a lot of the times the volume is unknown. So that's where our variables are going to come in. Let's now look at a mixture problem. In this video, I'd like to go over an example of a mixture problem. Now there are two main types of mixture problems. This is the first type, and let's just read through this, make sure we write down exactly what we're looking for, introduce some variables, and be able to solve this. So how many liters of a 40% acid solution should you mix to 20 liters of a 20% acid solution to obtain an acid solution that is 35% acid? Now, the problem with word problems, and what most students do when they read through this, is that they will immediately try to take this information and just put it together into one equation. If you try to jump right to an equation, you're sure to either become too frustrated, get something wrong, or just get angry and continue to hate word problems. So what I'm going to do is to approach this in a few different ways. The first way is to write down exactly what we know in this problem, and specifically the pieces of information that are going to be incredibly important for us when we go to solve an equation. Write an equation and then solve it. So the first thing I have 3 bullet points here, and what I want to write down are the things that we're going to need and the things that are necessary to complete this problem. The first thing that is absolutely necessary in this problem, and we need to keep track of, is the volume. So what is the volume of each solution? Notice we're talking about liters. Now if we were talking about maybe a metal alloy, we'd be talking about weight. It could be kilograms, it could be pounds, whatever, or just grams. So here we're talking about the volume of a particular solution, the amount of that solution. That's going to be important. The other thing that's going to be important is the concentration of the solutions that we're talking about. So here we're talking about acid. So these are the concentration or the strength of the whatever we're talking about. In this case, we're talking about acid solutions, so we're talking about 40%, 20%, 35%. That concentration is going to be important. Now, when we consider the volume of that solution, the amount, and the concentration, when we put those together and we multiply those, what we're going to actually get in this problem is the acid content. So, for example, I'm just going to write over here. If I have 50 liters of an acid, let's say I have 50 liters of a solution, and I know that it's 10% acid, then I can multiply those. 10% of 50 liters is 5. So this would be my acid content. So if we know the volume, we know that concentration, then we can multiply those to figure out the acid content. Okay, so that's going to be important. Now, the other piece of information that's very challenging, at least with these word problems, is organizing the information. What I typically recommend for students to do is to draw a picture. In any mixture problem, really what we're doing is we're taking two quantities and we're putting them together, and we are producing a third quantity. So here we have a little bit of acid solution, here's a little bit more, and when we mix those together, we will have another type of acid solution. Now, I'm going to, using this picture, bring down that information from up above, the volume, the concentration, and the acid content. So up above, if we can also read the words, it says how many liters of a 40% acid solution should you mix to 20 liters of a 20% acid solution to obtain 35% solution. So right then and there, I know I am taking let's say a 40% acid solution. I am mixing that with a 20% acid solution, and when I mix those two, I want to obtain something that is 35% acid. Now hopefully you can see why I chose 40 and 20 on this left side and 35 on the right side. It's because, according to the problem, I'm mixing a 40% solution and a 20. Those are the two I'm putting together, and I want that to equal, when I mix them, a 35% acid solution. So hopefully this picture is okay here. Now underneath each one of those, I'm going to write the volume. Do I know the volume of each one? Well, it looks like it says how many liters of a 40% solution. I don't know that. I do know 20 liters of the 20% acid solution, so I'm going to write 20 liters right underneath that. And I want to obtain an acid solution that's 35, so I don't know this one either. So I don't know what this is. Now it's asking specifically what or how many liters of the 40% solution. So if I'm looking for that, I'm going to put an X there. That's what I'm looking for. X is going to be the amount of the 40% solution. How did I figure out putting an X there? It's because that's what I'm explicitly asked to find.
So that's what I'm going to represent as the variable. Now over here, the volume of the 35% solution. This actually, although we don't know this, we can now write an expression for this. The reason why is if I have 20 liters, I'm starting with 20, and I'm adding x to that, some unknown amount, that means my final volume is going to be 20 plus x, or x plus 20. Right, let me say that again. In this case, I know I have 20 liters here. I don't know what this is. I don't know what this is an unknown quantity, so I'll call that x. And then when I add these two together, I'm going to get my final product, final volume of 20 plus x. Now finally what I need to do is to consider the acid content. So if I know this is 20% of 20 liters plus 40% of x liters, that needs to equal the acid content at the end. And that's essentially what I'm looking for. I'm looking to compare the acid content of this left-hand side of the equation with the right-hand side. So if I wanted to describe the amount of acid mixed together on this left-hand side, I can do that by multiplying 20% times 20 liters, 40% times x liters. And what I know is that better equal 35% of the total volume. And that's how we figure out and solve this problem. So if I were to write this out, you would have 20% of 20 liters. So if you're multiplying with a percent, you know that needs to be changed into a decimal. 20% of 20 liters plus 40% of some unknown amount of liters needs to equal 35% of the volume of the right-hand side here, so that's 20 plus x. So now I just need to go ahead and solve this. 20% of 20 is going to be 4 plus 0.40x. And now I need to distribute. This is just going ahead and solving. 0.35 times 20 is 7 plus 0.35x. So all I'm doing here is I am solving. I'm going to get the x's on the same side. And I'm actually going to subtract a 4 from both sides as well. I'm kind of running out of space here. So I'm just solving this one variable equation, getting x on the same side. 0.05x will equal 3. Okay. So when you divide by 0.05x, or just 0.05, excuse me, what you're going to get is you're going to get 60. You're going to get 60. So what did we find when we found x equal to 60? Well, let's go back to the original problem and see what x represented. If I go back to my picture, I see here that x represented the amount of the 40% solution. So that is 60 liters. I would have 60 liters. 60 liters. I already know I have 20 liters over here. Right? I have 20 liters of the 20%, 60 liters of the 40%, which means my total volume at the end is going to be 80 liters. However, in this problem, this is truly what we are looking for, right? Up above it says how many liters of the 40% solution. So just a quick recap. If you try to jump right to the answer and try to jump right to calculating, how do we get an equation? How do we do this? Do I just write down the numbers and write an equation? That's typically what students want to do. They'll just try to pull the numbers into this problem. It needs to be approached a little different manner, and that is we need to consider a few things. First of all, we're given the concentrations and the volumes. Those pieces of information are going to be very important. So I need to consider with my picture, what am I mixing together? And drawing these three rectangles is a good way to get started. I'm mixing this 20% and this 40%, and I'm obtaining this 35%. So just knowing where the concentrations go. Underneath that, I wrote the volume of each one. Since I was looking for the volume of the 40%, that's what got the x. Right. Now, finally, the acid content comes into this matter when we have to consider, when we're mixing the quantities on the left, the acid content needs to equal the amount of acid on the right-hand side. So when I put this 20% and 40% solutions, when I mix them together, it needs to have 35% of that volume of 20 plus x. So that's why they're equal to each other.
In this problem, we are asked how many milliliters of a 15% alcohol solution should you mix with a 30% alcohol solution to obtain 75 milliliters of a 25% alcohol solution. So we have lots of things going on here, but as you can see, I've already drawn the three mixtures, because on the left-hand side, I'm combining these two, and when I add these two mixtures together, it will equal this combination here on the right. Keeping in mind that we're always looking for, in this case, we're talking about alcohol, we're looking for the alcohol content. In the last problem, we were looking at the acid content. But as you know, what I would recommend is you draw this picture. Inside, we're going to describe with numbers, we're going to describe the percentage. So think about the two that you're mixing together. Which combinations are we mixing? If you read the problem, it says we're mixing how many milliliters of a 15 should you mix with a 30. So we're talking about a 15% solution, and we're combining that with a 30% solution. And what we know is that when we mix these two together, what we want is a concentration of 25%. Now, remember, we're talking about, and in order to describe the alcohol content, we need the concentration, but we'll also need the volume of these pieces of information. So what of these three do we know? If you look at up top, it says that we don't know 15%. That's what we're looking for. We actually don't know how many milliliters of the 30% solution. What we do know is that when we're done, at the very end, we want 75 milliliters at the end. So this is actually the only one that we know. This is the only amount of milliliters that we know on the right-hand side. We need 25% solution and 75 milliliters of that. It turns out we do not know either one of these things. We don't know the amount of the 15%. We don't know the amount of the 30%. What we need to do is to introduce a variable and then use that variable to write an expression for that other unknown. So since I don't know one of these things, I'm going to call one of them x. I'm going to call the 15% solution. I don't know this volume. I'm going to call it x. Now, if I do know that this x, when I mix it with this amount, it gives me 75, I actually can write an expression for this 30% solution. And to get that, I would write 75 minus x. This should make sense intuitively. If I have 10 liters of the 15%, this would be 65, because I know when I add them, I have to get 75. If I have 5, this will be 70. If I have 25, this would be 50. Well, how am I getting this 30%? I'm always subtracting it from 75. So again, we wrote in our concentrations. I know the volume of my final product. These are the two quantities I don't know. That's where my variables and my variable is going to go, and that's where my expression is going to go. Keeping in mind that in order to solve this problem, what we need to be able to do is to write an equation describing, in this case, the alcohol content. So if I wanted to describe the alcohol content for this side, the left-hand side, that would be 0.15 times x. I would add that to 30% of this volume, which is 75 minus x. And on the right-hand side, I would have an alcohol content of 0.25 times 75. Now, before I start moving things around, I want to simplify both sides. So over here, I still have this 0.15x. I need to take 0.3, multiply that by 75. I get 22.5. And then minus 0.30x. You don't need that 0 there. 0.3 and 0.30 are the same, but I'm keeping that just kind of as a placeholder. And then finally, on the right-hand side, if I were to figure out the alcohol content, 25% of 75, this is 18.75. So now let's combine some like terms here. I have 0.15 minus 0.3. If you subtract those, you'll get a minus 0.15. And then I'm also going to, actually, maybe I'll just write this down. There's x plus 22.5 equal to 18.75. Now I can subtract this 22.5 minus that from both sides. Now, I know some students look at this and say, wait a second, you have a negative number. We're talking about volume here. How can we have a negative volume? We don't have, although we have a negative number in the process of solving this, our solution, we're not done yet. So let's wait till we get to the end. Then if you have a negative number, you might want to go back. But right now, I'm just solving this for x. If you subtract those, you get minus 3.75. And then finally, if you divide both sides by that 0.15, what you should get, in this case, x is equal to 25. So this was just my steps, solving equations, combining like terms, moving things around. I got my variable x equal to 25. So let's go back and see, what did I call x? Well, up top here, x was the volume of the 15%. So in this case, I would need 25, and my unit is milliliters, 25 milliliters of the 15%, which means what would I need of this final piece? I would need 25 away from the 75. I would need 50 milliliters. Whoops, that doesn't look like 50. 50 milliliters. So if I had to answer the original question, how many milliliters should you mix? Well, I would need 25 milliliters of the 15% solution, and I would need to mix that with 50 milliliters of the 30% solution. What makes this problem different than the last problem was that maybe I'll start with, what are they similar? How are they similar? We're still combining two solutions and they're producing a third. What makes this problem different is that in this case, we know the volume that we want at the end. We know we want 75 milliliters at the end, which means my expressions that I need for the two that I'm mixing together are going to be slightly different than in the previous problem.